So hello students. So again I welcome you all on this YouTube channel. So let us solve one more question. So this question is based on three-phase induction motor, right? And this question has been asked in your examination in ESE 2008, right? So let us solve this question. So just please read the question statement. What is the operating slip of a 400 volt 50 hertz 6 pole 3 phase induction motor while the speed is 936 rpm revolution per minute with a 400 volt 48 hertz 3 phase supply? Right? So do you understand the question? Right? So have you understood? So this is he is asking operating slip, right, of a 3-phase induction motor with this rating, right? 400 volt 50 hertz 6 pole induction motor is there, and he is asking the operating slip of this induction motor when it is operating at 400 volt 48 hertz, right? And when it is operated at 48 hertz, in that condition the speed is 936 rpm, right? So in that case you have to calculate the operating slip. So these four are the option A, B, C, D. Out of these four options, only one option is correct, and you have to choose that correct option, right? So how to calculate this? So I told you the operating slip of an induction motor S is equal to, you know what is a slip? Slip is nothing but it is the difference of the two speeds. What are the two speeds? Speeds are rotating magnetic field and rotor. So slip is nothing but the difference of rotating magnetic field speed and the rotor speed, and it is always expressed with respect to the synchronous speed, right? It is always determined with respect to ns. So what is a slip? It is the difference of rotating magnetic field speed ns and the rotor speed nr, right? And it is always expressed as a percentage of synchronous speed, right? ns. It is always expressed with respect to synchronous speed ns, right? So this is a slip. I have already explained the slip in great detail in 3-phase induction motor. Please look and watch that video on this YouTube channel, right? So this is the operating slip of the induction motor, right? So now he is asking that, so this the operating speed of this induction motor is 936 rpm, right? So if you want to calculate the slip, then you should know the rotor speed. Rotor speed is already given 936, right? This is the rotor speed, 936 rpm, right? And synchronous speed you have to calculate, right? You have to first find out the synchronous speed, because rotor speed ns is given to you 936 rpm, right? So which synchronous speed you have to take? That is a question. So that's the only point that you have to take into consideration, that you have to keep in mind. See here, this is the induction motor which is being designed to operate at 50 hertz, right? It is an induction motor which is designed to operate at 50 hertz. But he has connected this induction motor at 40 hertz supply, right? He has not connected this induction motor as 50 hertz, right? He has purchased this induction motor from the market with this rating, that means 400 volt 50 hertz and 6 pole induction motor, right? This is a nameplate rating, right? But he is not connecting this induction motor at 50 hertz. right? He is connecting the induction motor. Instead, he is connecting the induction motor at 48 hertz supply, right? So the synchronous speed will also be corresponding to the 48 hertz supply frequency, right? That's a point, right? So now calculate the operating speed, right? So calculate the synchronous speed ns. It is given by the basic relation 120 f by p, right? So 120 f is a supply frequency, which is definitely 48 hertz, right, and not the 50 hertz, remember, right? Number of poles are 6. So when you calculate this, you will get 960 rpm, right? So this is the synchronous speed, right? It is a synchronous speed. That means it is that speed at which your rotating magnetic field is rotating in air gap between stator and rotor, right? So you know this is the induction motor, right? So in air gap, this is the speed of synchronous speed of rotating magnetic field ns, right? With this speed, your rotating magnetic field is rotating, and the rotor is rotating at what speed? It is rotating at 936 rpm, right? So now you calculate the slip. So ns you have calculated at 48 hertz, right? At 48 hertz ns is calculated, and that ns, that is synchronous speed, is 960 rpm, and rotor speed is given as 936 rpm. ns divided by ns, 960. So when you calculate this, you will get 0.025, right? So the operating slip when the supply frequency is 48 hertz is 0.025, right? So now you understand? You understand now? So 0.025 is the operating slip. So which option is correct? So can you tell me the correct option? Which option is correct? So definitely option A is correct. Option A is correct. So first option, A option is correct, right? So in this question you have to only keep in mind that the synchronous speed ns would be corresponding to the applied frequency to stator, and here in this case the applied frequency to the stator is 48 hertz and not the 50 hertz. So how do you know this? Because how do you know this, that supply frequency is 48 hertz? Because he is giving you the speed, operating speed is 936 rpm at 48 hertz. So this operating speed of rotor is given as 936 rpm, and it is at this frequency 48 hertz. So the synchronous speed of rotating magnetic field will also be the corresponding to this 48 hertz, right? So option A is correct. So now see here, if you calculate this, if you calculate the synchronous speed ns at 50 hertz, right, in that case this ns synchronous speed will come at 1000 rpm. So when you calculate at 50 hertz, which is wrong, so when you calculate the slip at 50 hertz, then you will write 1000 minus 936. So divide by 1000, then you will get the answer 0.064, which is wrong, right? So this is a mistake which one can commit, that he can calculate the slip at this synchronous speed corresponding to 50 hertz, right? So synchronous speed, where you calculate at 50 hertz, 120 into 50 divided by 6. So 120 into 50 divided by 6, 6000 by 6, you will get 1000, right? So in that case, if you calculate ns, the slip, you will get 1000 minus nr is 936 divided by 1000. So in that case, you will get 0.064. C you will get, but this is not the correct option, right? Because in this case you are taking rotor speed at 48 hertz, that is 936 rpm, and you are taking the rotating magnetic field synchronous speed at 50 hertz, corresponding to 50 hertz, right? Instead you should take the synchronous speed ns corresponding to 48 hertz, which is 960, definitely 960 rpm, right? So this point you have to take care, right? So here option A is correct. So the synchronous speed corresponding to the applied stator frequency, and which is in this case 48 hertz and not the 50 hertz. So right, so thank you very much. So if you like, you can subscribe for all such kind of questions, right? So thank you very much. Lot of thanks.